Regression means prediction. You can predict the x value, you can predict the y value for a x value where x is not in the data set, that is not in the observations, but within the smallest and the highest value of the x. So in that case, regression, linear regression can be used for predicting the y value. Linear regression should not be used for predicting a y value for a x value which is outside the range of the x values. This is called as extrapolation. So regression, linear regression should not be used in case of. So supervised learning and unsupervised learning are the two categories. In supervised learning, we have classification and regression. Regression is for continuous variable as an output. Classification is used when we have discrete dependent variable. Classification can be binary or multi-class. Logistic regression is preferred to be used with binary classification problems. Right? Pass fail, yes, no, defective, not defective, so on and so forth. Repeat in quick steps. In linear regression, what was the problem? That the linear regression line was getting carried away by the outliers. So what we have, we instead of using a linear regression, we prefer to use a function called a sigmoid function. So we'll come to this, what it is. Sigmoid function. And what is the sigmoid function doing is that it is classifying the probability into class 0 or class 1 binary classification. Now, what is that probability? The probability for this problem is that is when the timing chain will break. So probability of breaking the timing chain. So if that probability of breaking the timing chains falls between 0 to 0.5, it will be classified as 0. That is, timing chain will not break. And if the probability of breaking comes to be 0.5 to 1, in between 0.5 to 1, it is classified as 1. So meaning that the timing chain will break for the given reading. This is modeled using sigmoid function. Now in linear regression, we had equation of the form y is equal to mx plus c, y is equal to beta or beta 1, beta 0 or omega t x plus c. Now instead of using this equation, what is used is called as a sigmoid function, and calculate the probability, and based on the threshold, classify this probability to class 0 or class 1. That is what is basically done in logistic regression. Now, the sigmoid function is generally represented as y is equal to 1 upon 1 plus e raised to x. Just to give a glimpse, I'll again repeat, is that this is a derivation and the sigmoid function is y is equal to 1 upon 1 plus e raised to minus x. So how the logistic regression is derived is that you have y is equal to p upon 1 minus p. So you take log of p upon 1 minus p, that is probability of success upon probability of failure. And then you take exponent, and this is simple derivation where you get logistic regression is equal, logit function equal to 1 upon 1 plus e raised to minus beta 1 x plus beta 0. As the exponent term has the original equation of regression y is equal to mx plus c, and this the word regression comes in, but it is based on log. That's why it is called as logistic regression. This is how the sigmoid function is there. And then the evaluation or assessment of logistic regression is done using something called as a confusion matrix, which is basically 1 and 0 of predicted against 1 and 0 of actual for a test data set. And there are 4 categories. True positive means that the predicted value is 1 and actual value is 1. True negative, predicted is 0, actual is 0. False negative, predicted is 0, but actually it is 1. And false positive, predicted is 1, but actually it is 0. To have a model with 100% accuracy, you want true positives and true negatives to be at a maximum value, and false positives and false negatives at 0 value. So that will make your accuracy to be exactly 1 or 100%. There's another metric called as precision that is considered. So precision is basically true positives divided by true positive plus false positive. Okay. So this is another metric which is called as precision that is used for evaluation of the logistic regression.